So this is my video response to the two-button calculator. So if we had only two buttons, plus one and times three on a calculator, we're trying to find the fastest way to get to 300. So I did it by the method of exhaustion, which means I listed every possible procedure that you could push on a calculator and determined which was the fastest that way. So I did that by making a tree diagram. So I know we first started out with 0, and so we know we have to add 1 simply because 0 times 3, however many times, is always going to be 3. So our first move is a plus 1. And then from there, I began my tree diagram. So you could either go two ways. You could either times by 3, which would give you 3, or you could either add 1, which would give you 2. And I continue to do this, so you would have 2 right here. Sorry. You would have 2 right here. And this would be times 3 is 9, plus 1 is 4. 2 times 3 is 6, and 2 plus 1 is 3. So I continued to do this, and then I made larger. It kind of got big, so I just continue to do it for every single one. Now I'm not going to do it all here, but I did list them all. I did list all of the possible outcomes, and I eventually found that the fastest calculator pushes was in 9 clicks. And it consisted of plus 1 times 3 times 3 plus 1 plus 1 times 3 times 3 plus 1 times 3. And I figured that since I listed every single procedure that you could go through, I found that this was the fastest way you could obtain it in 9 clicks. This clearly isn't the only possible method, but this is the method I chose. However, I wonder if bases are somehow related to this problem. When I mean bases, I mean, since we usually count on a number line in bases of 10, how would this work if we counted in bases of 3? So our new number line would look something like, so if this is our number line, we would start out at 0, and we would go to 1, 2, and then we would have 1, 3.